All right. Good afternoon, everyone, and welcome to the first session of the Recreate webinar series titled From Composite Materials Waste to Value. My name is Sebastian Zuzek. I'm a part of Recreate communication team, and we are very happy to have so many of you here today, project partners as well as external partners for the launch of this monthly webinar series. The series is part of the Sharing Circularity event stream, which is curated by the Circular Business Academy. At this stage, I'll kindly ask our project coordinator, Gianmarco Griffini from Politecnico di Milano, to say a few words for us.
Thank you, Sebastian, and welcome everyone. I'm very happy to have this webinar series starting. And I'm actually very happy to have the first of all speakers today who will be talking about, let's say, the overview on the challenges of making composite materials circular. So we will be listening to a few of our project partners, and I hope you will all enjoy. I'm not sure how things will be, let's say, organized in terms of questions. If we have, I suppose, Sebastian, will have a chat, right? So we will probably collect the questions in the chat and then maybe have a Q&A session at the very end, right?
That's right. Thank you. Thank you, Gianmarco. So like you said, today we have four exciting topics and speakers from our consortium. First up is Luca Gentilini from Haiki Cobat, who will provide a valuable overview of composites market. Then we got Stefan Zaba from EDA Group, who will present circular design for composites on an automotive showcase. Following him will be Daniel Mickelmeier from Carbon Cleanup, who will present their approach to transforming composite waste into high-value products. And last but not least, we've got Herfit Lama, who will present how HET is applying Recreate technologies in producing sports equipment. And like Gianmarco said, there will be opportunity to ask questions after each presentations. So please raise your hand or post your questions in the chat. And at the end, we'll also have some time for discussion, hopefully. So thank you again for joining us. And without further delay, I'll hand over to our first speaker, Luca Gentilini.
Yeah, thank you, Sebastian, and hello, everybody. Today I have the role to basically introduce the reference market, which is basically studied by the Recreate projects in order to find solutions for the sustainable management of end-of-life composites. And in order to do so, it's better to understand what we're talking about in terms of market, not only meaning volumes and values, but also meaning characterization of the products inside the market, of the value streams, the value chains, and so on, in order to understand which are the potentialities related to finding more sustainable, also economical solutions for the end-of-life management of such products. And despite this will be a short presentation, the whole webinar will be very short. We will touch several points. We will see, first of all, the market in terms of volumes, the state of the art when it comes to end-of-life management of composites.
Sorry to interrupt, Luca. We can see the presenter mode.
Oh, sorry, I thought I was seeing it, but you were not.
No worries.
Okay. Should be good now.
Perfect. Thank you.
Thank you. The possibilities I was saying to exploit landfilling to manage composites, and then an example of technical characterization of composite-rich products in order to stress the idea that composites are not all the same, and treating end-of-life composites must be declined into the single sector, the single products, because each product is unique and each product must be addressed with a customized circular economy solution. Starting from the volumes of the market, just some figures in order for you to grasp some key points about the importance of the composites market in Europe, which basically yearly sees more than 2,500 kilotons of new composites products introduced in the market. The composite market is dominated in terms of volume with glass fiber, of course, based products, while despite carbon and other fibers like aramids, Kevlar, and so on are less present in terms of volumes, are more valuable, and therefore they account more when it comes to the economic figures and not the volumes figures. And the application of composites is very horizontal, meaning that they are exploited and they must be exploited for their unicity in terms of the combination of strength and lightweightening in several sectors like transportation, electric and electronic equipment manufacturing, construction, sport and leisure, also everything related to energy and wind energy, for example, and so on. Therefore, we are talking about very valuable materials used in many different value chains. And we will see later that the characterization of these value chains, of these products, of this assembly plays a crucial role in the sustainable and optimized management of their end of life. Then, in order to provide you a whole picture of where let's say we are studying innovative solution with Recreate, there's a short mentioning about the state of the art when it comes to the end-of-life management of such products. Nowadays, optimized solutions are not viable yet, because the things that you can do currently at industrial level with composites are basically either to remanufacture them, most usually with a downgrade of the application of the composites. For example, here you see on the right former wind blade, which have been cut to become like games for kids, outdoor games. But of course, you can do pilot examples of this strategy. You cannot do it on a large scale, also considering the volumes of composites that are really introduced on the market, as we saw before. And then the things that are currently industrially viable are mechanical recycling, but with a dramatic downcycling, basically, of the properties of composites, which are then used as a filler, basically, for thermoplastic molding, mostly. Otherwise, you can apply co-processing, meaning the shredding of the material for energy recovery in either energy production plants or cement clinks. And all these strategies imply, of course, a downgrade of the performance, of the high performance of the composite materials. And this is where we study where we stand, basically trying to find more optimal solutions for the sustainable and virtuous end-of-life management of such products. On top of that, despite at European level and at single nations level, there are more than one initiatives to ban landfills. Very generally speaking, in Europe, landfilling of composites is still a viable option, and this furtherly complicates, let's say, the reference market when it comes to proposing sustainable solutions for the virtuous end-of-life management of composites. On top of that, and this will be the key point of my very short presentation, very condensed presentation, let's say, it's important to understand that generally speaking, we are talking about composites, carbon composites, glass fiber composites. But when it comes to the real market, each material is embedded in unique products with unique life cycles, and therefore, in order to propose a valuable solution for the end-of-life management of composites, you have to keep in mind not only the composites as a material, but the unicity of such materials in different products, and therefore to apply value chain oriented, single value chain oriented solution for the interception and recovery of composites. One example that we give here is the unicity, let's say the peculiarity of the composite parts used in the wind blades, which are one of the more iconic, let's say, examples of composite materials used in the industrial sectors. Wind blades usually exploit glass fiber, but more modern use also carbon fiber, and usually they have a high fibers to matrix ratio, and composites are embedded in a more complex structure, which is not composite pure, but also has other materials like fillers, balsa, paints, metallic components like bolts and cables and so on. And therefore, the recovery of composites means also the targeted recovery, let's say, dismantling of more complex products in order to be able to reach the composites and to treat them appropriately. On top of that, wind blades of different generations can have different fibers, for example, different technologies of fibers, glass, carbon, other fibers, and so on, and different combination of fibers, because also multi-fiber blades exist, where glass and carbon coexist to create a hybrid, basically a structure, which of course will need, when those blades will reach the end of life, dedicated solutions which will be different from the, let's say, simple recycling of glass fibers, single recycling of carbon fiber. And to conclude, as promised, I have been very quick, let's say, in order to give space to the proper technical presentations of this webinar. What we tried to do in Recreate was to assess this complex market, this multi-stream market where composites are involved, and to find peculiar solutions for the circular economy management of composites, not as a commodity, let's say, not as a single family of materials, but as peculiar components which needs to be addressed by specialized and optimized technologies. And again, being very quick in presenting everything, I try to summarize all the complexities which are basically present in the complex market related to the circular economy treatment, to the circular economy management of composites and composite-based products.
Thank you, Luca. If there are any questions, this is the time to speak up. If not, Stefan can take the floor.
Yeah, good afternoon, everybody. Stefan Zaber from a company called EDAC. I'm trying to share my screen right now, and this is going to be it. You see the presentation screen or the wrong one?
Nothing yet.
Nothing yet.
for now.
Okay. Okay. Yeah.
Yeah, here we go. Something is loading. We can see your screen. It's again in the presenter mode.
Okay, and this is and now it is better.
We can only see the PowerPoint layout now.
I love it. Now it should be working because I now only see the right picture.
I can still see the PowerPoint layout, but I'm not sure about the others. Maybe try
confirm.
to close the presentation and try it again.
There you go.
Now we can see.
Now we go.
Yeah.
Okay. Okay. As I said, I'm from EDAC. EDAC is one of the largest engineering service provider for the automotive industry, but not limited to automotive. We are part of this project because we are really looking forward to achieve circular economy, and that's why we are starting with composites, because here it's one of the hardest things to reach circular economy. If you are taking a look at automobile industry today, we are facing towards electrification, which means we need more resources. We have today more weight by that, which means we have reduced range and less payload. We need, on the other hand, electrification brings us long-lasting drivetrains, which means the vehicles could possibly drive more than the usual 200,000 kilometer. We have less maintenance required. That's also a good benefit. But now we come to the point that the chassis and the body in white are designed for shorter life cycles than the powertrain is. Usually the powertrain was the limiting factor, and now we are reaching the point that the chassis and in particular and also the body in white are the limiting factors. Using composites here could be quite helpful because composites are high durable. They cannot rust. They offer lightweight design, which reduces the total cost of ownership. We have lower use phase emissions, but on the other hand, we are facing specific obstacles due to composites. We have high material and production costs. We have an energy-intensive production, in particular of the carbon fibers, and related to that, we have the high emissions. They're very difficult to recycle, even though we are working on solutions. And today they are not as repairable as they could be. Which means today the vehicles, which are designed for short-term use, like passenger vehicles, cannot monetize the composite advantage, even though it's given. What are we talking about? If I'm talking about vehicles, I don't solely talk about passenger vehicles, as you may have in mind now. It is for sure the largest market, but this also includes other vehicles like light commercial vehicles, heavy trucks. This also includes buses, agricultural vehicles, mining vehicles, or any other specialized vehicles, agricultural vehicles, new models which are not existent today but have a very high growth and special requirements, and other new opportunities in the new mobility sector. So the sector of mobility is huge. It's really, really huge. It's billions and billions. It's a $1 trillion business, a €1 trillion business. It still shows high growth rates, which are not only on the passenger vehicle side, but more on the new vehicles which are coming up. And this creates new chances for composites. So how are we tackling the problem that composites could have a benefit, but they actually do not have? The first thing is, if you want to reach circularity here, which is solving the problem more or less, we need non-detachable joining for recovery of parts. Recovery enables repair, replacement, reuse, refurbishment, and at the final stage, an improved recycling. For that, we are exploiting different possibilities for detaching parts from the structure. And in addition to that, we are working on designs of components and of joints which are adapted to circularity, which are utilizing the benefits of detachable joining methods. And on the other hand, we are looking for demo cases for utilization of those benefits. One of the best demo cases is a vehicle concept that we presented some years ago. We call this the CityBot. The CityBot is like a tractor, but this tractor is working in the inner city, and you can attach different modules to it. These modules are doing different jobs, like road cleaning in the night, supervising the communities, but they can bring you to work, they can deliver you parcels, they can do some gardening work. Whatever is imaginable is based on this small tractor unit at the front, which means this tractor unit isn't used for 23 hours per day, which speaks for any investment into lightweight design, into durability, and this is exactly what composites can offer. Based on that, we have developed a concept together with the partners from the project. We were working in particular on debondable adhesives. We have two different concepts. One is the Inda primer, which is offered by Atlas Rescal. It's a primer system which includes a system which is more or less detaching or debonding at an elevated temperature. It's available at for different temperatures. In this case, we examined the 170-degree version. On the other hand, we were using thermally expandable adhesives. These thermally expandable particles in the adhesives, you can imagine it like popcorn. It's popping up at a distinct temperature, and it's destroying the adhesive, which is at the end debonding the adhesive. We tested numerous load cases, as you can see, at room temperatures, at elevated temperatures. We did a climate change test. We checked the vibration resistance, and we found out most of the demo use cases are possible. Most of the loads can be bared, and if one solution doesn't fit, the other one usually does. On the other hand, we were working on those joining elements. We created a system of joining elements which can be used to combine different carbon fiber reinforced profiles to create lightweight design, which is debondable, detachable, repairable, reusable, whatever you can imagine, anything which is related to a circular economy. And we think this is a good possibility for utilizing the composite advantages. Then we brought this into our CityBot. Here you see a picture of the CityBot tractor unit. This is the one which is driving for 23 hours per day. And we really redesigned this model. And the good news is we could save 52% of the weight. This is quite huge. And this is at the end creating huge benefits in reduced energy consumption. On the other hand, we achieved increased stiffness and increased durability. We increased the stiffness by about 10 times the stiffness that a usual passenger vehicle has, which means, on the other hand, we have a high driving comfort and we do not have to care too much about durability again because it's really very stiff. On the other hand, it's repairable. You can just use a heat gun to disassemble one or two of the profiles if something gets broken due to a small crash or any other thing. The elements are reusable. And at the very end, they are recyclable, and not in a way that we have a big mixture like Luca just showed in the wind power blades. Now we have really only carbon fiber reinforced plastics for being recycled and at the end being brought back to the market. But this is not where we stop. As the consortium, we are offering different services which may be helpful for anyone who might be interested in that. We do not want to produce this vehicle for again and again, since we are engineering service providers. What we offer based on that is we offer our experience on how to implement such systems also to any other vehicle or maybe any other machine. So whatever is necessary for developing a product, design, prototyping, conceptualization, also lifecycle assessment and testing can be bared by the team to establish circular composite solution, no matter which kind of product it is. And for that, we are combining our forces. Here you see the partners involved. This is not only us, this is also our partner Invent, this is Eplas Rescal and our research partners Fraunhofer IWU. And we offer you an experienced team. You just have to call one of us and you get the entire team. We will develop your modular structures with detachable joinings. We will offer you all the knowledge that we have, and we will generate you a durable and lightweight design for enabling circularity from composites. So thank you very much for listening to my small talk. And if there is any question, don't hesitate to ask.
Thank you, Stefan. Any questions? Okay, then we are moving on with Daniel.
Yes, hello.
Welcome to take the stage.
I hope you can see the presentation.
Yes.
Perfect. Then, hello, ladies and gentlemen. Welcome to my presentation about Carb-E, transforming waste into high-performance products. I'm Daniel Michelmeier. I'm junior researcher and product engineer at Carbon Cleanup, and I will guide you through this presentation. And first of all, who are we? We at Carbon Cleanup were founded 5 years ago by Mr. Radanic, who has 20 years of experience in material science and special machine engineering. Therefore, with him as our lead and us as his specialist team, we are producing microfactories that are there for mechanically recycling composites with carbon fibers and glass fibers as our focus to our vision in closing the loop on all composite materials. Therefore, let me show you what we do. We have 3 business units that we are also provided in Recreate. First of all, our microfactory. This microfactory is, like mentioned before, a mechanical recycling microfactory for composites, and our goal is to get the fibers out of the composite. With 3 fractions, we get fiber needles long, fiber needles short, and carbon dust. With them, we provide you with sustainable materials that are perfect for BMC, SMC. Also, with a step in between, we can compound our materials for using in injection molding and large format additive manufacturing. And also with one step further, we provide you with filaments for standard FDM 3D printing. And also with our technology and development team, we can help you in your company with your product stream to identify the best ways to get the product waste out of your company into our carbon ether and give you back the recycled materials. The most asked question we get usually is, why are we doing this when you can use virgin fibers that are performing better than our recycled material? We have already seen the picture of the landfill of the wind turbines, and that we are just wasting land and volume. and also still performing fibers. Therefore, we try to save all kind of waste before they're getting to the landfills, that we can process them, recycle them, and provide our partners and customers with the free fractions I already mentioned. And also, when you think of the aviation and automotive industry, the part of composite materials is steadily increasing, but for the end of life parts, there is not a real solution on how to deal with them unless you fill up landfills and get not really good fibers out of it until you use our microfactory, of course. And for the composite waste generations, the legal frame is already changing. For example, if you look into Germany, into Austria, the Netherlands, or Finland, it is already illegal, or it's banned to fill up landfills with composite materials. And also with the increasing pressure of the European Union on countries, that they also want to increase the ban of composite materials. And for the overall people, the pressure is there for automotive industries to use more sustainable and recycled materials and not only use the virgin fibers. And how are we doing this? For example, for the carbon ether, we are inputting your end-of-life materials or product waste that you generate, feed in with our microfactory. For example, the size you can see, it's almost comparable with a shipping container. So it's high mobile, and it's also very high efficient in the electrical power usage. So for example, for 1 kilogram of carbon fiber we are recycling, we are only adding 0.036 kilograms of CO2 to the material. And this is all achieved without any solvents, without water, acetone, or something like that. And it's also dust free. All you get out of the machine is filtered air and high-performing carbon fibers that, like mentioned before, you can reuse into your product with PMC, SMC, or compounds. For carbon cleanup, as a Recreate partner, we are providing you with the technology of the mechanical recycling, also then seen as the recycled materials. Right now, I want to mention for the benchmark study, our senior researcher, which is sadly not available today. She is making the benchmark studies between pyrolysis, solvolysis, electrofragmentation, and our mechanical recycling. For the recycled material we provided EDAC with our filament, but more of that later in another slide. And for the key exploitable results, we work together with HEAD, that we got the product waste of tennis rackets, and then we tried to close the loop with the material, sent them back our materials to make pickable pellets or rackets. More of them also later. There's another slide for that. For transforming the waste into the high-performance product, I want to show you the demo cases. Like mentioned beforehand, the transforming of the tennis rackets you can see on the left-hand side. HEAD provided us with this material, sent it to us, we recycled them or processed them in our machinery, selected the perfect fibers for them, and then sent them back to transform it into a closed loop system, like the pedal ball racket you can see on the right-hand side. Well, I'm also holding in my hand right now. We are making them already. This was one of our demo cases, and the second one was to provide EDAC with the FDM printing filament. Therefore, we used the recycled carbon fiber. It was compounded with PETG. Sorry, the feedback we got was that it was easy processability, and it was ideal for the prototyping of the already mentioned CityBot from EDAC. On the right-hand side, you can see the printed connectors, they printed out of our materials. And also with a week ago or 2 weeks ago, EDAC got an innovation award, the first place, with their idea, their connectors, and we are a little bit proud that they used our materials for that. Yeah, thank you very much for your attention in my presentation. If there are any questions, please feel free to ask them, and thank you for your attention.
Thank you very much, Daniel. Thank you for also showcasing both demo cases. I think this is a good introduction for the last presentation. I would kindly ask Herfried to also present how HAT is using the Recreate technologies.
Can I ask one question to Daniel?
Of course. Yes, please.
Yes, of course.
Okay. I wanted to ask, you talk about your KI. Is it possible to scratch the materials just like that without cleaning it and all of this thing?
I didn't catch the question, I'm sorry, but
I mean, is that possible? Do you have a machine just to shred the samples material
yes,
from mechanical recycling
yes.
without cleaning? I mean,
what do you mean? We are looking into when you give us the parts, we're cleaning them first. Like for example, when you have some foam or something like that in the material, we try to get rid of the excess material just to get the composite into the machinery, if this is your question. And then we will mechanically recycle it, and within the technology of our carbon ether, it is then separated into the three fractions. Like fiber needles long, we are talking about fibers longer than 4 millimeters. The fiber needles short is in the range of 0.1 millimeter and up to 2 millimeters. And then with our carbon fiber dust that is separated into in the filters. I hope this answered the questions. But we are separating the excess materials we don't need before we feed the carbon ether.
Okay. All right, thanks.
You're welcome.
Good, thank you for the question. There are no more questions. Herfried, you're free to start.
Okay, thank you for Daniel for the overview, and thank you for your time there. And I might also answer this question from our point of view regarding how clean those parts have been we did send back to carbon cleanup there. And I also will give you an overview how we use this technology for demonstrators for our products. It is changing. Sporting goods is a little bit different to automotive there, and yes, it is lightweight is a key enabler, and composite is for sure one of the best material with all its properties behind it to allow a perfect performance of our product. And therefore, when we talk about our product is always performance oriented and less material oriented there. So we need to deliver a certain performance with our product. If it's a tennis racket, a pickleball racket, at the end, you want to win the game against your opponent. And what is behind, nobody really takes care, neither sustainability nor what is in there. Weight is an issue, and therefore, most of our products, say it be skis or let it be a tennis racket, are composites at the very high end, and we use virgin fibers normally, and we get those products out there. And to see what it is, I show you this video to give you an overview what we are doing and what you expect from our product normally. So that are typically sporting goods. I hope many of you have many of our products and others in hand there. And I come what was presented already, this demo case here and Recreate. How can we use, let's say, from a racket to racket? We have seen tennis racket in the video. Here on the left side, you see also one of those examples there. And there, typically, you use only UD carbon fiber pre-breaks, something which is not yet available in that performance characteristics we need to recycle, not even after recreate there. But as mentioned by carbon cleanup, yes, it's possible to get shorter fibers. And with these shorter fibers, it's possible to do some isotropic properties on a flat surface. And with sports like paddleball or pickleball, we have such a flat surface, which is or should be as isotropic as possible there. So we did look into various ways to use these shorter fibers. We used our own rackets. We did take off the grommet sets there. We did off the wristband and so on there. So we somehow cleaned them. But then they were taken inside the carbon ether with all the cosmetics on it still there. And those particles we did get back there. We then look into it, how thin we can make a plate out of it there, and can we use this thin plate for our flat rackets like pickleball and paddleball there again. The performance characteristics need to be the same. So in principle, you want to hit the ball very easily. The ball should have a certain speed back there. And this is much more important than looking only on values like Young's modulus or strengths and so on there. Typically, the Young's modulus is one part of the stiffness. As you think of these flat rackets here, of course, the thickness of the layer has also an influence. So at the end, with some compromises in weight, with some compromises in thickness, with some compromises on the Young's modulus, we have been able to demonstrate that we could keep the performance on an acceptable level for average players there with the recycled materials. And ideally, these recycled materials coming from old rackets. For skis, the world is a little bit different. Skis are mainly made of glass fibers, and there also the process of just shredding is cheap. It is not so easy to really be here also economically feasible there. There we went into a different way. We stripped down separate layers of material there, and we did try to keep the wooden core of the ski, the glass fiber laminate there, as unchanged as possible there. As mentioned from Stefan before, some parts of our products as well there are able to withstand a much longer lifetime, and that's the composite part there. So by taking away, let's say, the top sheet, the racing base, the edges, and renew them, it's possible also to demonstrate and to recycle a ski again there. When you send us these type of skis back, we can build new skis and bring them back into the whole cycle there. Overall, such composite parts can take about 5 times the typical lifetime of a ski. And with the renewed racing base, with renewed edge, there will be no loss in the performance of the ski. And this is, in short, our contribution to recreate. Are there any questions? I think that's it. Should be, yes. Are there any questions?
Okay, thank you, Herfried. There are no questions. You're of course welcome also to contact us after the webinar, and we'll get you in contact with all of the presenters today. So hopefully you can see my screen right now.
Yes, we see your screen.
Okay, great. It's really been a pleasure to host all of you today. Thank you very much to all the speakers for providing all of these valuable insights in such a short time, and of course to everyone in the audience for joining us today. The recording of the webinar will be available on our website, and you will also get an invitation to our next webinar, which is coming up in November on Wednesday, 26th of November at 12. You're also welcome to register through the QR code. And again, thank you for being part of today's webinar. I hope you learned some valuable insights, and we look forward to seeing you next time.
Thank you, everyone. Enjoy the rest of the day.
Thank you.
Thank you. Bye-bye,
Thank you.
everyone.
Bye-bye.
Bye.
Bye-bye.
Thank you.
Bye.
Bye-bye.
Bye.